Algebra 2 students. I'm Mrs. A, and I'm about to start Algebra 2, the Saxon second edition Algebra 2 book. If your book looks like this, these lessons are going to work for you. I'm doing these for my granddaughter Hannah right now, but I'm hoping that maybe some of my other homeschooled grandchildren will use it in the future, and perhaps you are not one of my grandchildren and you are tuning in because you happen to be using this book. That's great. I'm glad you're here. Send me a little email and I'd be glad to say howdy. I'm also glad to answer any of your questions if you have them. And we're going to start with lesson 1 in this book. This book has some extensive review lessons, A and B. I'm not going to cover those in the videos. You can just do those in your book. I'm going to start with lesson 1. Here we go. Okay, so the very first section, section 1A, is about polygons. And we start by defining polygons. Poly means many and gonon means angle. So a polygon is a figure with many angles. But that was old definitions. We've honed that a little bit more. You see in the book, the author has a very interesting explanation. But simple, closed, flat geometric figures with straight sides is a decent definition of a polygon. So in your book, you have some pictures. I'm going to show you your book now. Okay, so here, triangle, quadrilateral means 4 sides, pentagon, 5 sides, hexagon, 6 sides, octagon, 8 sides, and octagon, 8 sides. So this is a regular octagon. Regular means all the sides and the angles are the same. This is a very irregular octagon. Now down here, these are figures that are not polygons. This one crosses over itself, kind of like a bow tie. That is not a simple figure. This figure crosses over itself. It is not a simple figure. It is not a polygon. This figure starts well, but then it has a rounded side. All the sides must be straight. That is not a polygon. And this one is not closed. You see, I can escape through that gate there. That's not a closed figure. Therefore, it is not a polygon. So here we're talking about a simple, closed, flat geometric figure whose sides are straight. We're going to use that definition in this book. Now up here at the top, it says, note that in each figure, the number of vertices or corners is the same as the number of sides. So here we have 3 vertices and 3 sides. That's a triangle. Okay, so basically 1, 2, 3, 4, 5, 6. Those are 6 vertices and 6 sides. 4 vertices and 4 sides. So this is an equilateral, meaning all the sides are the same. You see how they put hack marks on all the sides? Now, all the angles are not the same, are they? This is equiangular, meaning all the angles are the same. This one is concave, meaning it's got a little, it dips in. So that is concave polygon. But they are all going to be polygons. This one is equiangular, equilateral. But notice that that one does not look like all the sides are the same. All right, so down here, we have a concave polygon and a convex polygon. So it says in figure B here, it has an indentation that we can think of as a cave. This polygon is called concave. Okay, any polygon that does not have a cave is a convex polygon. Now we can tell that we have a convex polygon if between any 2 points anywhere on that polygon, we would never leave the figure to go outside. But you see here how I have point A and point B, and I would actually leave the figure to go outside. If I drew a straight line in between them, that is concave. It has a little cave in it. This one is convex. No matter where I draw the points, there's no way for me to go outside the figure drawing a line between 2 points. Okay, so here we are with our 5 sides, 5 sides, 7 sides, 7 sides. But you can see, we're in the middle of page 22 in your books right now. You can see that this 5 side and this 5 side look nothing alike. This one is a regular pentagon, which means that it has all angles and all sides are equal to each other. And so all the angles are the same, all the sides are the same. This is a irregular pentagon. This is a regular heptagon, 7 sides, and this is an irregular heptagon. So if it has the same, all sides have the same length, and all angles have equal measures, that is a regular polygon. So they're giving you a lot of definitions in this section. So down here, they're giving you names and number of sides, the name of the figure and the number of sides. So number of sides, name, number of sides, name, so that you can learn to categorize a polygon by the number of sides. So 3 sides is a triangle, 4 is a quadrilateral, 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, 8 is an octagon. Now over here, we have special names for 9 sides, nonagon, 10 sides, decagon, 11 sides, undecagon, and then 12 sides, dodecagon. But then if it's more than 12, we call it an n-gon. So if we had a figure with 23 sides, we would call it an n-gon. If it had 23 sides, we would call it a 23-gon. Excuse me. So at the very bottom of this page, we can see that we have diagonals drawn. They're trying to define a lot of terms in between you. If we have 2 endpoints of the same line, we would call those consecutive vertices because they're right next to each other. Okay, if we have 2 sides of a figure that are right next to each other, we would call those consecutive sides. And then if we have 2 vertices that are not consecutive, we had a line in between them, that would form a diagonal. So this figure has several diagonals. You could go here, you could go there, you could go from here to here, or from here to here. Okay, so we have diagonals connect non-consecutive vertices. Okay, so in your books, we're now on page 23, which is 1B. We're talking about triangles. A lot of definitions in lesson 1. A right triangle has 1 right angle. That's the most that you can have in a triangle. 1 right angle is a right triangle. Right means 90 degrees. Obtuse means we have 1 angle that is greater than 90 degrees. So this one is obtuse. And then acute. I always remember that, a cute little baby. So we've got acute angle, smaller than 90. All of the angles are acute. Okay, down here, the next section, we're talking about the sum of the measures of the 3 angles in any triangle is 180. Now that is one of the most important rules in geometry that we can ever have, and we're going to use it a lot as we encounter things in this book. The greatest angle is opposite the longest side. Now this makes sense, okay? So here we have A and C. We go, which one is longer? But if we know that the greatest angle is opposite the longest side, then we know that side C is going to be bigger or longer than side B, because this angle is over only 70, and across from it is B, and this angle is 80, and across from it is C. So since this is the bigger angle, it opens up to the bigger side. So we have here the greatest angle is opposite the longest side, and the smallest angle is opposite the shortest side. Very important rules. Okay, so here we have 3 angles. We go, well, which one is the biggest one? So we look at the sides. This side is 10, and 10 is greater than 9 or 7. Since 10 is the greatest side, A will be the largest angle. Okay, since 7 is the smallest side, the angle opposite from 7 will be the smallest angle. And 9 is in the middle, so this is your middle angle, the middle measure of all three angles. Here is another important rule. In a triangle, the angles opposite sides of equal angles will have equal measures. If we understand this one up here, then doesn't that one make sense? If we have angles that are the same, wouldn't it make sense that the two opposite sides would also be the same? Okay, so now in a triangle here, we have 60 and 80, okay, 60 degrees and 80 degrees. So we have 80 is opposite. This side will be longer than the opposite to this angle, which will be this one. Okay, since we can figure out this angle over here, there's 180 in a triangle. There's 80 right there, so 60. This one must be 40. Since we know this is 40, this is the smallest side. This is the middle. So this is going to be the middle side. This is the largest angle. So this will be the largest side. We have no angles the same, therefore we have no sides the same. That is a scalene triangle. Okay, here we have an isosceles triangle. We know it's isosceles because we have these two little hack marks that show that these sides are the same measure. Because those two sides are the same measure, guess what? This angle must be equal to this angle down here, because this is the angle that is opposite that side. Since the sides are the same, these two angles must be the same. This isosceles triangle will always have two equal angles and two equal sides. There at the bottom of page 23 in your book, you have an equilateral triangle. Equilateral means all three sides are the same length, which means that all three angles will also be equivalent to each other. Okay, now here at the top of page 24, it says each angle must have a measure of 60 degrees because they're talking about that equilateral triangle that we just saw on the page before. Since this triangle here has three equal sides, it must also have three equal angles. Since three equal angles must go into 180, it makes sense what they're saying up here, that each one of the sides each one of the angles must be 60 degrees because you have three equal angles, and three equal 60 degrees put together would give you the 180. Okay, since an equilateral triangle has at least two sides whose lengths are equal, an equilateral triangle is also an isosceles triangle. So every equilateral is also isosceles, is what they're saying here. So here are two rules that they're putting in boxes. If two sides of a triangle have equal lengths, the angles opposite these sides have equal measures. If two angles of a triangle have equal measures, the sides opposite these angles have equal lengths. So it goes both ways. Okay, so then this next one says, when the three sides of a triangle have equal lengths, all three angles are 60-degree angles. If the three angles of a triangle equal, they must be 60-degree angles, and the three sides must all have equal lengths. So now we have some examples to apply these rules. Okay, so it says find x and y. So here we have 50 degrees. We also know something. We know that this hack mark and this hack mark here tell us that these two sides are the same. If these two sides are the same, that means that the angle opposite, which is 50, and the angle opposite, which is x, must be the same. So 50 must be x. So now we have 50 and 50. That's 100 degrees of our triangle. That means y must make up the difference between 100 degrees and 180 degrees. So y must be 80. And they're explaining that here. Okay, so on this one, one, example 1.2, we're to find x and y again. So we have x, we have y, we have 40. They tell us that this external angle here is 150. Since this angle and this angle make a straight angle, that means together they must equal 180 degrees. So 150 from 180 is 30. That means x must be 30. This one is already stated to be 40. 30 plus 40 is 70. 70, we have 180 degrees in a triangle, so 70 from 180 is 110. That means y must be 110. And here they show you. This one is 30, this one is 40, this one is 110, and altogether they get 180 degrees. The last little example in that section says this triangle is an equilateral triangle. Find D. So we look over here to the problem, and they have D, C, B, and A, and they tell us that it is equilateral. Since it's equilateral, don't we have to have 180 degrees out of angles that are equal? And that's 60, 60, 60. All equilateral triangles must have 60-degree angles. If this one is 60 and D is going to be a straight angle with it, remember straight angles are two angles that add up to a straight line, which is 180 degrees. If this one is 60, then what does D have to be in order for this one to be 60? And the two of them together add up to 180. So D must be 120, and there's also a rule that you're going to learn that this exterior angle is the sum of the two angles opposite. We'll learn that one a little bit later, but that's also a handy one because this one is 60. This one has to be 180 minus 60. But if this one is 60, don't these two added together also have to be 180 minus 60? So it's just another cool rule to get your work done quicker. So now we're going to move to 1C, transversals. Now I think transversals are particularly interesting and a lot of fun to work with. So a transversal is simply a line that crosses two or more other lines. Okay, so if the lines that it crosses are not parallel, then we would say that L is not parallel to M. So we have this little symbol here. Let me see if I can get it bigger there. Two straight vertical lines, and then a transversal means not parallel. So T or L and M are not parallel. But over here on this side, it shows three parallel lines, N, M, and S. And the transversal is P. And the rule is, since the transversal is perpendicular to one of the three parallel lines, then it must be perpendicular to each one of them. So S is parallel to M is parallel to N, because that's what that says. And because P is perpendicular to the first one, it is also perpendicular to each and every one, which leads us into an interesting rule, okay? That when we have two parallel lines cut by a transversal, then we have, you see this angle is marked L, and this down here is another angle marked L, meaning they're the same measure. This is the larger angle, a larger angle, but then see, since this angle is larger than 90, this is a smaller angle. Together, the two angles make a straight line, so they're straight angles. This little angle will be 180 minus the larger angle. And so we have this one and this one, the two L's, are what we call vertical angles because they're going to have the same measure. You can see that this opening between two lines has got to be the same as that opening down there. These are vertical angles. These two S's are vertical angles also. So they must be the same. But look down here. Because this angle is in the same position on parallel lines, this line is not bending. The transversal is cutting these two parallel lines in exactly the same angle. So L, L. This one was S up here, so it's S down there. This one was S down here because of those verticals, therefore it's S down there. This one has to be L because those are vertical. This one has to be L also because they are corresponding. So let's look at this paragraph here and understand it a little bit better. Okay, now the top part, they're talking about the parallel and not parallel. Okay, if we have these little arrows here in the Saxon math book, those mean that they are parallel lines. You see how that's got just a little arrow and a little arrow. Those are parallel lines. That's how the Saxon book denotes parallel lines. Okay, but let's look down here. If the transversal is not perpendicular to the lines, two groups of equal angles are formed. Half the angles are large angles because they're greater than 90, that are equal angles and are greater than 90. So L, 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 they're all the same angle. And then it says half the angles are large angles that are equal angles and are greater than 90. Half of the angles are small angles that are equal angles and are less than 90. So these two angles, large angle and the small angle, must add to 180 because isn't this a straight line? So that is the straight angle right there, isn't it? Well, then look at this one right here. Because this transversal is here, isn't this a straight line? So 60 and 120, aren't these straight angles together? But then look here. This is also a straight line across that line there. So these are also straight angles. And straight angles are the same thing as supplementary, right? They add together to be 180. And then again, these right here. The same thing is going on down here on the bottom. Okay, so if we had three parallel lines, then wouldn't the pattern continue? L, L, L. Across from it would be the supplementary angle S, S, S. Vertical to the L's is another set of L's, and vertical to the S's is another set of S's. So we have a situation to where that entire picture has only two angles that are going to be the same. Okay, on this one it was 120, 60, 60, 120, 120, 60, 60, 120. Doesn't matter how many parallel lines you decide to put here, you're always going to have just two angles in that if every line is parallel. And then the transversal is going to have to cut them all at the same angle. So here it says on the left, we use the letters L and S to mean large and small. We note that together, a large angle and a small angle form a straight angle. So the large angles and the small angles are supplementary angles. In the center figure, the large angles are 120 angles, 120 degree angles, and the small angles are 60. Thus, the sum of any large angle and small angle is 180. In the figure on the right, we see that when a transversal cuts three parallel lines, then we get 6 equal large angles are formed. So basically 1, 2, 3, 4, 5, 6 equal large angles, and 1, 2, 3, 4, 5, 6 equal small angles. All right. Okay, so in this section we have example 1-4, and it says find A, B, and C. Now they give us one angle, But over here, we had two angles all the way up, but we knew that if we had one of them, the other one had to be supplementary with it. So we only need one angle to figure out all the others. Okay, so if this one down here is 60, let me see if I can make that a little closer. If this one is 60, then A must be supplementary with it. 60 plus 120 gives us 180, so A must be 120, which it tells you right there. Let's see if I can get that a little higher. Tells you right there that A is 120. And then we know that this A must positionally be the same as that B. We call those corresponding angles because they're in the same spot. So A must be B. Therefore, B must also be 120. Okay, and that's what they say down here. B is 120. And then lastly, C is supplementary with B, which is 120. So C must be 60 again. Okay, so now 60, 60, because those would be vertical. And then 60 here would be matching the 60 up there because they would be corresponding. Okay, so we only knew one, and here's the explanation here. Angle A and the 60 angle form a straight angle, which measures 180. Thus, A must be 120. Lines M and M are parallel, so all the angles, small angles are equal, and all the large angles are equal. Thus, C equals 60 and B equals 120. So now we're going to go into the last little portion in this lesson, 1D, proportional segments. Okay, so here on proportional segments, it gives us a very important rule right here at the beginning. When three or more parallel lines are cut by two transversals, the lengths of the corresponding segments of the transversals are proportionate. This means that the lengths of the segments of one transversal are related to the lengths of the corresponding segments of the other transversals by a number called a scale factor. So let's see a picture of this. Okay, so here is a picture that is three parallel lines and two transversals. Okay, so it says in this figure we use arrowheads that are not on the ends of the segments to indicate that P, M, and N are parallel. So I want you to see what they're saying. Those arrowheads are not on the end of the line, therefore they mean that these three are parallel. When we have three or two parallel lines cut by transversals, two of them, then all of the segments will be proportional to each other. So the left to right scale factor for this figure is 3/2. So basically they're saying if I take 2 and multiply it by 3/2, I get 3. If I take 3 and multiply it by 3/2, I get 9/2. So the scale factor for this figure is 3/2. If I were going the other direction, 3, I would have to flip this over and make it 2/3. 3 times 2/3 would give me 2. 9/2 by 2/3 would give me 3. Okay, so the scale factor always depends on which direction the scale factor is going. So you see down here, they're actually showing, hey, we're going from left to right. Therefore, we're going to get 3/2 is going to be our scale factor. Okay, so they have a little table here showing you all of that. So in the same figure, the scale factor from right to left is 2/3. So if we're going this way, the scale factor is flipped over. This number is the reciprocal of the scale factor from left to right. So it doesn't matter if you have to use it the other direction, you just have to flip over the scale factor. So the segment length is 3. We're going from right to left. So we started with 3, we're going backwards, and we multiply by the reciprocal of this one, which is 2/3, to get 2. And they're just showing you how this works all the way through. So now let's look at the next example. Example 5, the arrowheads indicate that the lines are parallel. So you see what they're saying. These are telling you that they're parallel. So over here we have a 2, and over here we have an 8/3. Over here we have a 5, and over here we have an X. So let's figure it out. Okay, so I am going to do this one for you on the board. This is example 1.5. We're on page 26. And it's the last example before we do some practice problems. So we're starting with 2 and we're going to 8/3 because we have 3 parallel lines indicated by the little arrows here. And we have 2 transversals, which are not at the same angle. Then we start here with a 2 and we have to go to 8/3 because they are proportional lines because of these parallels. Then we know that 2 times something is going to give us 8/3. Okay, so we figure that out. 8/3 divided by 2 is going to be 8/3. Divided by 2 is multiplied by 1/2, right? When we divide by 2, we multiply by the reciprocal. And 8 divided by 2 is 4. 4/3 should be our scale factor. So we check it. 2 times 4/3 is 8/3. That means that if we were going this direction, we would start with 8/3 and we would multiply by the reciprocal because we're going the other direction, and we should get 2. And we do get 2 because we'd have the 8 and 4 canceling out to give us 2. So we figured out this one. Okay, so the cool thing is that scale factor stays the same. So the scale factor from here to here is 4/3. We're going to multiply by 4/3. Therefore, we're going to use the same scale factor times 4/3 to get 5 times 4/3 must be X. So that's going to be 20/3. When we multiply 5 times 4/3 is 20/3. Okay, since this was an improper fraction, it's fine and expected to leave that one as an improper fraction. This one is 2 2/3, and this one would be 6 2/3. But since this one was left improper, we would leave them both in improper form. But generally in Algebra 2, we don't use mixed numbers much anymore. We usually leave things in their simplified improper form. So there you have your answer. If we were going the other direction, and this was the missing number, then we would multiply by this one by the reciprocal of that one. So I think you're going to find that these are pretty much fun and easy. All right, so now we're on our practice problems. And we have an ABC triangle. And remember, when we have 2 sides the same, we call that isosceles. And when we have 2 sides the same, that means that we have 2 angles that are equivalent. So opposite this one, C, and opposite this one, A, must be the same angle. Therefore, since we already know in this problem that A is 35, then C must also be 35. So if we have a 35 and a 35, that's 70 degrees already accounted for. There are 180 degrees in every triangle. So 180 take away the 70 means that this one up here, I'm not going to make it that way because then it makes it look like they're the same. This one up here would be 110 because 110 plus 70 is 180 degrees. And that's all there is to that one. I'm trying to get the shine off my board, but it's nighttime now and I get a glare. Okay, here's example B. And we are to find X and Y. Now we have enough information. If we didn't have this one here, we'd be in trouble because we would only have the 40 and we would have 2 more unequal angles to figure out. That would be too much for the information. However, we've got this 145 over here, which is an external angle, and it is supplementary to x. So 145 plus what equals 180? Well, that answer is 35. So x is 35 degrees. And then these two added together will give you 180. Then you have enough information because you got 35 plus 40 plus something else gives us 180. So 35 plus 40 plus y equals 180. Okay, so now 35 and 40 is 75 plus y is 180. Therefore, all we have to do is take 180 minus the 75 to find the missing angle y, and that's going to leave us with 105. So y is 105. So x is 35 and y is 105. It's as easy as that. Okay, here's practice C, and we have parallel lines with a transversal cutting, which means that all of these angles must be the same. So 130 must be the same as twice b. So we're going to figure out what b will have to be. If twice b is 130, then don't we just need to divide both sides by 2? And we get b is 65. Okay, b is 65. So then we know that this is 130. These two must add to 180. Therefore, a must be 50, which means that c, which is corresponding, must also be 50. Okay, so corresponding angles must be 50. Now, watch this. If we have this angle and this angle, those are both 130. So this angle right here would be 130. This angle right here would be 50 because they would be vertical. So if we were going to complete the chart, which we don't have to, 50, because it's the underneath angle here, would also be 50 here. And then 130 is down here, so 130 would be down here. Okay, and that would give you all 8 angles. But you are only supposed to figure out what is B, what is A, and what is C. Last practice problem. Okay, so here we have transversals. Okay, we have parallel lines and then 2 transversals. So we know from our rules that that means that the segment, these intersection points, these segments made by these intersections are going to be proportional, which means there's a scale factor between them. So what would I multiply 3/4 by to get 5/3? Well, let's see. What is 5/3 divided by 3/4? That is the same thing as 5/3 times the reciprocal 4/3. So 20/9 is the scale factor. So 20/9. Okay, so you can see the 4 and the 20 are going to cancel with the 5. The 3 and the 9 are going to cancel with the 3 in the denominator. That same scale factor then must also be multiplied by 6/5 to find this missing number. So 6/5 times 20/9. So I'm just saying we're multiplying by that to get this one right here. Now I'm going to use a little bit of cancellation. 5 and 20 gives me 4 right there. 6 and 9 gives me a 2 and a 3. So now I've got 2 times 4 is 8. 1 times 3 is 3. So 8/3 is the new x. That's all there is to it. Y'all go have fun with your homework now. This is Mrs. A, and may God bless your day.